All right, here's a couple questions off of the back of that Calorimetry 1 sheet. So here's number 1. There's just 2 questions on there. There's 1A, B, and 2A and B. So it gives you this reaction. This is a combustion of a compound called ethine. C2H2 is ethine. First thing you would need to do is figure out the delta H of this reaction. Okay, and you do that by using your heats of formation sheet, doing products minus reactants. So the overall delta H of this reaction would be the heat of formation of this times 4 plus the heat of formation of that times 2 minus the heat of formation of this times 2 plus that, which is 0, has nothing for heat of formation. So our overall delta H, again, this is 2 times water's heat of formation, 4 times carbon dioxide's. So products minus reactants. So the overall delta H is about a negative 2,600 kilojoules. Remember, they'll write that as per mole of reaction, per mole reaction. All right, so that's the first thing that would have to happen if that's not given to you. Second thing, 250 grams of this is burned. So they're burning 250 grams of this. And the heat transferred is going into some water, 300 kilograms of water. So you have this huge thing of water. You have 300 kilograms of water, like on a stove, that is being heated. And it's at 25 degrees Celsius to start with. It's going to go up in temperature as we burn this. So we're burning this ethine. The ethine heat is going into the water, making it go up. So first thing we're going to do is a little bit of stoic and figure out how much heat 250 grams of this would produce. So 250 grams of C2H2, 200 grams into moles. And C2H2, I should know off the top of my head, is 26 grams. And then for every 2 moles of C2H2, there's 2,600 kilojoules of heat produced. So burning 250 grams of this makes 12,495 kilojoules of heat. That heat is going into that water and raising its temperature. So now we can do MC delta T for the water. So we can go, I'm going to erase this. We can go Q equals MC delta T. Remember, your specific heat is in joules. So you maybe would want to put this into joules. It's also in grams. So you maybe want to put that into grams. Since this is in kilojoules, this is in kilograms, you actually could leave them because they're on opposite sides of the equation. Otherwise, you could put this into joules and that into grams, whichever you want to do. So 12,495 kilojoules equals 300 kilograms times 4.18. I'm just going to go, what is the change temperature going to be? So take this, divided by the product of those, and your change in temperature for that water is 9.96 degrees Celsius. So burning those 250 grams of ethine makes temperature go up 9.96 degrees. So add that to 25 degrees. Temperature would now be 34.96 degrees Celsius once it's done. All right. One more question I'll do on this one. What volume of oxygen at 27 degrees Celsius? We're trying to figure out liters of oxygen at 27 degrees Celsius, 820 millimeters of mercury, is required to react with an excess C2H2 so that 40 kilojoules of heat are released. Now, we know there's 40 kilojoules of heat released. We're trying to figure out volume of oxygen. We know temperature, we know pressure, trying to figure out liters, so we need to know moles of oxygen. So our delta H, remember, was 2,600, so we can say there's 2,600 kilojoules per 5 moles of oxygen. Remember, that was our delta H that was up here. So we can figure out how many moles of oxygen must have been used to make 40 kilojoules of heat. Technically, this would be negative, that would be negative, not going to make a difference for moles have to be positive. 0.077 moles of O2. And then we can plug those into PV and RT. Don't forget, you have to take this and divide it by 760 from there. I'm not going to do that math. You guys can do that. It's about 1.77 liters. All right.